Okay, so we're going to go through how to do a standard style question. Question is, for the curve that, find any turning points and determine their nature. So turning points are maxima and minima and points of inflection. That's what we're looking at. So for all of them, we write down the original. 3x to the fourth plus 8x cubed. So this is going to give us our y value when we have an x value. And we go and find the first derivative and the second derivative straight up, because we're going to need both of them. So it's 12x cubed plus 24x squared minus 96x. And the second derivative is 36x squared plus 48x minus 96. So the first equation, the original, gives us our points. The second one determines, like that's the y coordinate of the points. Second one tells us our stationary points, where they are, the x value only, x value. And the third one tells us about concavity. Okay. So, to find the stationary points, we let dy dx equals 0, and we try and factorise and solve that for x. So it's 12x cubed plus 24x squared minus 96x equals 0. So if we factorise that first derivative, we get 12. Sorry, 12x. Try again. 12x outside of x squared plus 2x minus 8. We're going to make it equal to 0 to find the stationary points. So either x equals 0, or if we factorise the brackets and equate that to 0, that's x and x, 4 and 2, and it's a plus and a minus. So therefore our stationary points are x equals 0, x equals 2, oh dear, and x equals minus 4. Now it's a good idea to put these in order, because then when you sub it into the second derivative, sometimes you can get your maximums and minimums mixed up. So there are 3 stationary points. So the first step is to sub them back into the y to find the value of the x. And I've done that already. Okay, so they're the 3 values. I've just subbed them in very quickly. And now I'm going to put them in order. So it's minus 4 minus 511, in order from smallest to biggest. 0 and 1 and 2 and minus 79. So let's do a real crude sketch of that. So you've got 1 point, say there, 1 there, and 1 about there. So it looks like this one's going to be a minimum, that's a maximum, there's a minimum. But we can't just do it by inspection. We need to sub the 3 x values into the second derivative. So how do we solve this? We've got to factorise it. So 12x goes into everything, and we're left with x squared plus 2x minus 8 equals 0. 8 12s are 96, aren't they? Yes. So either 12x equals 0, meaning x equals 0, that's our first stationary point. Or if we factorise the brackets as a quadratic, that equals 0, so it's a plus 4 and a minus 2. So therefore our other stationary points are x equals 2 and x equals minus 4. Now it's a good idea, we might just write that a little bit out there. Good idea to put them in order, because that's the way you draw them from left to right. So we've got minus 4, then 0, then 2. And there are stationary points, so to find the y values, we sub them back into the original equation. That gets us the y coordinates. So let's take them in order now. So if x equals minus 4, y equals, if x equals 2, y equals, and if x, actually, let's do x equals 0, because that's not in order, and then x equals 2, y equals. So now I need the original equation. Okay, so I've just calculated those. So they're my 3 points. So if I draw a quick sketch, that will inform me as to whether they're maxes, mins, or perhaps a point of inflection. So minus 4 and minus 511. Now it's not to scale. So it's about there. 0 and 1. I try and make it to scale a little. And then 2 and minus 79. Let's say that's about there. So it looks like it's going to be a minimum, a maximum, and then a minimum. But we better have a check of the second derivative. So now we've got the second derivative here, which we found in the very first part of the question. And if I sub the x values in, that's going to tell me about their concavity. Are they concave up or concave down? So the second derivative was 36x squared plus 48x minus 96. We need to sub each of our values in. So as I said, do it from smallest to largest, so we can go across the curve properly. So I'm just going to do y dash for ease and for space. Y double dash, sorry. So if I sub in minus 4, I get 288, which is positive, therefore that's a min, which we expected. If I sub in 0, I get minus 96, less than 0, so it's a max. And if I sub in 2, I get 144, which is bigger than 0, which is a minimum. So if I draw my curve, again, got a really low point here, smaller point here, so, and one there. So the algebra would now tell me that that's what it's looking like, and it does hit that 0, 1 point there. So we've got a min, a max, and a min. Now if we're talking about points of inflection on this one, there's no horizontal points of inflection. We know that the stationary points we got, which is when we made dy dx equals 0, we got 2 minimums and a maximum out of them. So there's no horizontal. But there is a point of inflection where the concavity changes, and it's around here. Now this one doesn't come out to be exactly in the middle of the two. Sometimes they come out to be exactly in the middle. This one must be a little bit skewed. If you want to find out exactly where this point is, you need to solve the second derivative, make it equal to 0, and it comes out as a surd, in fact. So there's a point of inflection here, around there, and there's another one here. So we're going to go and solve the second derivative equals 0 to find that change in concavity. So if we try and solve this, let's divide by 12. So we've got x squared plus 4x minus 8. Try again. 3x squared plus 4x minus 8 equals 0. And if you try and factorise that as a quadratic, it doesn't actually factorise. I've tried it. So let's go the quadratic formula, which is minus 4. So we're expecting some sort of surd here, as it won't factorise. B squared, which is 16, minus 4 by A by C, don't forget your brackets, all over 2a, which is 6. So if you have a look inside that square root, that's 16 plus 96, which will give you a third. So it's -4 plus or minus the square root of 112 on 6. So if we get a decimal approximation, it's approximately at -2.43 and 1.09. Let's have a look how that fits into our graph. So here's our curve, and what we found, the 2 points of inflection, which are not stationary points because the first derivative is not equal 0, just changes in concavity, occur around here and 1.09, so around here somewhere. And if we found the roots, we could classify that a little bit more, but for the moment that's enough. So we'll put a y on there, x on there, and I think we're done with this question. So do our 3 stationary points in order: -4, 0, and 2, and sub them in. So the second derivative for each of those. So I've just subbed them in to my calculator, and as I said in class, the numbers don't actually matter, it's the sign. So we get -4 is a minimum, it's bigger than 0, 0 is a maximum, it's less than 0, and x equals 2 is a minimum, which is what we thought from the graph before. If we sketch it, -4 is a minimum, 0 is a maximum, and 2 is a minimum. So it looks something like that. And then if we can factorise the original and make y equals 0, we could possibly find these roots. But in this case we can't. If you look at the original equation, you can't factorise it. So all you have to write on the graph itself are the points. So it's -4.